Artificial intelligence has quietly become part of everyday life on Earth. It drives cars, analyzes medical scans, predicts weather patterns, and processes more data in a single day than a human could in a lifetime. But today, artificial intelligence is doing something very different. It is searching for places no human has ever entered. Beneath the surface of the moon, hidden underground, are vast structures formed billions of years ago. And now, AI is helping us find them. For a long time, the moon was considered simple and lifeless, a quiet world of dust and rock, shaped only by asteroid impacts, a cold satellite that seemed unchanged for billions of years. But scientific data tells a different story. Billions of years ago, the moon was volcanically active. Molten lava flowed across its surface, and in many places it flowed beneath it, slowly forming vast underground tunnels, lava tubes. On Earth, such structures are well known. They can stretch for tens of kilometers, but their diameter rarely exceeds 10 to 30 meters. Even the largest terrestrial lava tubes remain relatively narrow. On the moon, conditions were different. Lower gravity and the absence of an atmosphere allowed lava flows to remain stable for much longer periods of time. According to scientific estimates, lunar lava tubes may reach hundreds of meters in diameter and extend for tens, possibly even hundreds of kilometers. The problem is simple. We cannot see them directly. Today, two spacecraft observe the moon from orbit, collecting detailed data. The first is Lunar Reconnaissance Orbiter, a NASA mission operating since 2009. It images the lunar surface at resolutions of less than 1 meter, creates three-dimensional maps of the terrain, and measures illumination and temperature. Its observations were the first to reveal deep pits and persistent shadows, pointing to possible entrances to subsurface caves. The second is Chandrayaan-2 Orbiter, an Indian mission that has been in lunar orbit since 2019. It complements optical imagery with radar and thermal data, allowing scientists to study the structure of the lunar soil and detect hidden anomalies beneath the surface. Together, these two spacecraft provide scientists with an unprecedented view of the moon, not only of what is visible on the surface, but also of what may lie hidden beneath it. Thanks to orbital observations, scientists were able to identify on the moon structures that could not be recognized before. These features are called lunar pits. Unlike impact craters, they have almost no material around them, and their walls often go straight down. This shape does not come from an impact, but from the collapse of the surface above empty spaces below. Among many such pits, there are a few that are important for understanding the moon's internal structure. The first pit is located in Marius Hills. It is deep and nearly vertical. Scientists believe it may lead into a vast lava tube beneath an ancient volcanic plateau. The second pit lies in Mare Fecunditatis. Its elongated shape suggests a collapsed surface roof, possibly connected to underground cavities. Another pit is found in Mare Tranquillitatis. From orbit, it appears small, but the deep shadow inside indicates a much larger void below. The fourth pit is located in Mare Ingenii, on the far side of the moon. This region remains poorly explored, suggesting that vast underground structures may exist beyond our direct view. Today, scientists receive a colossal volume of lunar images from orbital spacecraft. Over the years, these missions have accumulated millions of photographs of the moon's surface. A human can carefully examine dozens of images per hour. Artificial intelligence can process thousands, even tens of thousands, in the same time. That is why an AI system called ESSA, Entrances to Subsurface Areas, was created. ESSA is a specialized computer vision neural network designed to detect lunar pits and skylights, possible entrances to underground cavities. Most importantly, after analyzing less than 0.3% of the Moon's surface, ESSA has already identified two new candidate entrances into subsurface voids. The first is South Marius Hills Pit, located in the volcanic Marius Hills region, one of the most promising areas for discovering ancient lava tubes. The second is Belkovich, a pit, found at the Moon's northern latitudes. These regions are especially important because subsurface caves here may preserve water ice. There is also a second approach, automatic anomaly detection using a variational autoencoder, or VAE. This AI first learns what a normal lunar surface looks like, then highlights anything that deviates from that pattern, including volcanic pits and skylights. As a result, what would take humans years of continuous work, AI completes in days or weeks, leaving scientists not with millions of images but with a short list of real candidates, possible entrances into the Moon's hidden underground world. Today, we are beginning to understand that the Moon holds more secrets than we once believed. Beneath its cold surface, there may be vast, empty caves, formed by ancient volcanoes billions of years ago. Artificial intelligence only lifts the veil. It does not open the caves directly, it points the way. Every detected anomaly is a potential entrance into an underground world that may one day become a shelter for future lunar bases. Perhaps the first cities beyond Earth will not rise on the Moon's surface, but inside it. And when that moment comes, the history of lunar exploration will begin not with a step onto the Moon's surface, but with a step into the darkness.